So this and the next question, like the other question in the middle that I have done in the past, is really about the power of the eye. And I think that's a language that you need to know the definition of. It's in the textbook, so hopefully you read it, you understood it. Let me do a brief review in case you don't quite remember what we are referring to when we talk about power of the eye. Because, you've seen the word power in physics context before, like rate of energy transfer or rate of work done. It's not this. It's just it's a power that can be specified in the unit of diopter. That's a unit of power, and it refers to an optical element like a lens. So let's say you have a lens of focal length f. Then the power. What letter do I use? Let's just use capital P. Power of this focal length is 1 over focal length. That's it. So the unit of diopter, it should be unit of inverse meter. It's just the special name that we use in the context of optical elements, optometricians, so that they don't have to say inverse meter, they can just say diopter. Let's just double check to make sure that I didn't forget anything. Diopter, so 1 diopter in unit of meter raised to the power of -1. If I remembered everything right, it shouldn't complain. It should just tell me, yeah, 1D is 1 reciprocal meter. That's great. So whenever a question is asking you about a power of something in an optical setup, what it's really asking you for is the focal length. Once you figured out the focal length, then great. Just take the reciprocal of it, and that's the power. Make sure the focal length is in meters first. So this first question, it's asking you about the power of the eye. Okay, let's just start sketching. So eye, when we talk about it in context like this, it's basically a lens, or at least that's the part we are interested in. And it's already told you where the object is. So object is 60 centimeters away. So that's given us the object distance dO. So I'm looking for focal length. I remember the thin lens equation, 1 over dO plus 1 over di is equal to 1 over f. And staring at this for a while, I realize, so I'm looking for this, I know this, so I somehow need di. So it's the matter of, in this setup, so where's my image distance? Do I need to solve it separately? And this is where I think this hint is necessary, where it says, note, assume that the lens to retina distance is 2 centimeters. If you're looking at something and you haven't shown that, you are focusing on it, then that image of that thing that you are looking through your eye, the real sharp image should form on the back on the retina. That's the screen of your eye. So by telling us the lens to retina distance is 2 centimeters, the question is telling us just directly that at 2 centimeters away, let's do it this way, that the image forms here. And the focal length of the lens of the eye is whatever it needs to be so that this happens. So that image forms here, that's whatever it needs to be so that this happens. So the question actually gave us a di. So all you have to do is to solve for f. So let me do this in my head, algebra, by which I mean I'm just recalling my memorized formulas. Here, all you have to do, let me just take the reciprocal. I think I can do it that way. So I have Wolfram alpha. I can just plug in the numbers. 1 over the object distance, 60 centimeters. By the way, if you're using regular calculator, here I strongly recommend that you convert everything to basic SI units, to meters, to make use of this relationship here. Here, I can, because Wolfram alpha will do all the conversions for me, I can just type in distances this way, raised to power of -1, so that it does the reciprocal. And I wonder if diopter will be one of the choices it uses when it's giving me numerical values. Oh wait, that's the focal length. Oh, you know what? I didn't need to do this. Because once I have focal length, all I'm going to do is take the reciprocal of it to get the power. So let's just save us a step and not take the reciprocal of this. That is the power. So when I have that, it could be giving us inverse centimeter answers or inverse meter. And if you recognize that to be diopter, great. Type in 51.67, that's the answer. Or you can say in diopter. And Wolfram Alpha will convert the answer to diopter for us. 51.67. So you could round it to 51.7 and it should grade it as correct. Yeah, so that's that question. Pretty easy. Let me look at the other question, the second question. That should also be pretty easy. And one of the reasons I hadn't done this question is basically because I thought, oh, I've already done the one question that did deal with the power of stuff and how diopter relates to meter. And so I thought the other two, you can do it, but I'm trying to complete all the homework questions. I haven't done this, so let's do it, finish it. So in this what is the question telling us? What is the near point of a person? Okay. So near point, oh, I think I actually have to sketch that setup. Let me erase this and just sketch everything from scratch. Because the whole arrangement for the near point, it's a very specific optical arrangement you are looking for. I don't want to just hand wave it away or try to give a one phrase description of that. So it's asking for the near point and just saying the accommodated power of this. Oh, so I have no idea what accommodated power means. It's like a medical stuff, all the jargons and words. So what the question is explained is by accommodated power, all it means is it's the power of the eye, so the reciprocal of the focal length, when the focal length is at its shortest possible. Yeah, it feels like that's exactly describing a setup where, let's say, you're going to be doing this in lab soon, where you are placing something in front of your eye and you bring it until you can't focus on it anymore. So imagine that exact arrangement. You have the lens of the eye, and you have some object that you've brought into some close distance, and your eye, it's got this roundish shape. There's a retina back here, and so that's where your image will eventually form. So, and in this arrangement, it's kind of, I think I didn't quite draw this to scale. So let me just put a focal length at a position where it's not really realistic. But so when this forms that real image that forms on the retina, then it's going to look like this. This will be the real image. And so in this question, we've already been given the focal length. We've been given the focal length in terms of the power. I can type this into Wolfram Alpha in a way that relates to focal length. I can do that. It's all here. F is 1 over... Oh, I guess for power is D. Let me just use capital P. So we have focal length. And because they are still telling us, assume that the lens to retina distance is this, they are telling us the image distance. So it's again a matter of just solving the thin lens equation. 1 over DO plus 1 over DI is equal to 1 over F. For the object distance here, which, because of how we are describing this arrangement, this is the near point. That's the shortest distance where you can still focus and form a sharp real image in the back of the retina. So I need an expression for DO. Let me do this algebra in my head, which again means I'm just recalling the memorized formula. DO in terms of the other two. I think that's correct. So if DI is greater than F, this is, yeah, I think it's all right. Actually, let me do this algebra by hand. I'm suddenly starting to doubt myself. So doing algebra step by step, 1 over DO is equal to 1 over F. I move 1 over DI over, minus 1 over DI. I combine the fractions. So in the denominator, so I guess what you're imagining is you're doing this to each term. The 1 over F term, you are multiplying DI, top and bottom by DI, doesn't change the number. The 1 over DI term, you are multiplying top and bottom by F, doesn't change the number. Now they have the common denominator, so I can write down the combined fraction. di minus f divided by di times f. So that's 1 over do. So taking reciprocal of that, raised to power of minus 1. Then you get do is equal to this on top, di times f, divided by this on bottom, di minus f. I think I remembered it correctly before. But double checking doesn't hurt, and algebra practice, if you need it, also doesn't hurt. So the near point will be do here. Let's calculate that. So di is the 2 centimeter that's been given. And for f, let me just do it on the fly. It's going to be 1 divided by 53.7 diopter. That should give me the focal length, divided by the di, 2 centimeter, minus the focal length, 1 over 53.7 diopter. Let's see what we get for do. I guess they're asking for meter. So you get incompatible units. Sometimes, so it's helpful to check the unit interpretation. I think because of lack of parentheses here, the Wolfram alpha misunderstood if diopter is in the denominator or numerator. So I fixed that. And then, okay, so 27 centimeters or 0.27 meters. That feels far. I'm pretty sure. So I'm older than you, but even my near point isn't that far. I'm pretty sure. That's like it's all. That's an older person's near point. For most students in college, from having done the lab, your near point should be something like 10 centimeters. Like something around the 10 centimeters, the most common near point I've seen for young people. So. All right, so that's the second question that deals with really this quantity called power, which is related to focal length. So really, any question we ask in using diopters, we actually don't need to involve power. We can just let that question be about focal length. But diopters are like one of those units that are more common in a particular field, like optometry, because it's convenient. Because, if you say like a focal length of some lenses, I don't know, 3 centimeter or like 1.7 centimeters, and you change it tiny bit, like 1.75, and that's actually a big change. And when you specify it in diopter, I think like the difference between 50 and 55, how that feels, that actually matches how the numbers change. So it's a good thing to be aware of, but it's the kind of thing that if you ever forget and you need it for some work you're doing, then it's so easy to look up. You just Google search diopter. So